Okay, flat earthers, this will be the last video in my series tonight. This will be my last video for tonight, flat earthers. So I've been fascinated with the flat earth notion that the sun is much closer than 93 million miles and that the earth is flat and the sun goes around the earth. And I've noticed a few problems here. And it's something I wish I would have noticed, earlier on. But it's pretty simple. The amount of sunlight that I would receive if the sun is overhead, right? This is the flat earth version, right? I'm receiving this sunlight overhead at noon, very bright. And in morning and in evening, I see the sun disk is the same size, right? But I'm not getting as much sunlight, So the sun is going across the sky, it's going across the sky, then it, evening and, here's morning and whatnot. And yet the disk is the same size. Now, flat earthers will say that the sun is closer here than it would be here. And that would explain why the sun isn't as bright. Okay. So how is it that the sun is still, a third of a degree width in the sky? I said half a degree, but it's about a third of a degree, whether it be 20 miles away, 50 miles away, 100 miles away, or 2,000 miles away. And here's why I have to use these numbers, because the question is, when the sun approaches the horizon, and let's just erase some of the stuff here. Let's just try to get a little bit of clarity on this one. When the sun is going near the horizon, just before it touches the horizon, it's still the same size as it is high up in the sky, right? And then all of a sudden, then the flat earth perspective comes into play, where it spherically diminishes in size as it coincidentally goes at the horizon line. But we still have a problem. Even just before it reaches the horizon, just before sun, let's say a minute before sunset, that sun disk is the same exact size as it was at high noon, and it was way hotter at high noon and way brighter than it is here. Now, regular physics would tell us that the real issue is that the sun is far away, and it's essentially equally far away. I mean, 4,000 miles from here, right, to maybe here is really irrelevant when it comes to the Earth rotating compared to the 93 average million miles away. But what ends up happening is the amount of sun that you're getting is direct here, and it's coming at you at a more oblique angle here as you're rotating away from it. So this is where you are at noon. This is where you are at 6 o'clock. Okay, flat earthers? So if you guys could stop trying to confuse people with this notion that, if you're directly overhead, if the sun is directly overhead, it's closer than if it's at the horizon, because then you have a problem with the disk of the sun being the same exact size overhead, and you have a bigger problem. And the bigger problem, flat earthers, is that other people see the same size disk. So I always ask a flat earther, you tell me, how far could the sun be? What is the minimum distance that you'll say the sun is when it reaches the horizon? 20 miles, 50 miles, 100 miles, 1,000 miles. Because remember, other objects go over that horizon. You got other objects that go over that horizon, and they're going over that horizon at some location. And if you want to say perspective or whatever it is, once it gets to that horizon, it is some distance away. And whatever distance you want to claim that the sun is when it's overhead versus when it's here, you have to deal with the fact that that disk is the same size up to the point where it reaches the horizon. And you've got yet another problem, which is that you have people from far away. So if this is west, right, and this is, let's say, 100 miles away, why is it that if I go to South America, someone is also seeing the same sun westward? not northward, but westward. So you got a lot of problems here, flat earthers, and I'm here to simply destroy you. Thank you.